Here's another example of finding the inverse of a function. We're going to use our template again. The first step of the template is show the inverse exists. And we do that by the horizontal line test. So we've got to be able to graph the function. If we have a look at y, this is equal to y and f of x are interchangeable, so y equals the square root of 2x minus 3. We know that y equals root x, looks like that. That's y equals the square root of x. So it's going to be similar to that. Looking at the domain, possible values of x, well, we can see that we don't want this square root to be negative. So if x is anything less than 1.5, 1.5, that is going to be a negative, and so the function's not defined for x is less than 1.5. Is it valid for 1.5? Yes, it is. 2 times 1.5 is 3, minus 3 is 0, square root of 0 is 0. So that's going to work. So my graph is going to look a little bit like this. So y equals root x would start there. We've already said that it's got to be 1.5. And it'll go out and up like that. Okay, so there's my x, there's my y. And the horizontal line test just says there's nowhere I can draw a horizontal line and cut the graph twice. Okay, so theoretically this graph here goes on forever and it never actually flattens out. It gets less and less steep as it goes, but it never actually goes horizontal. Okay, so we've got horizontal line test, so we've got f to minus 1 of x exists. And that's sufficient to do that. Second step is to make x the subject. So this is my template. Make x the subject. And we've got, just write our equation down, the original equation, square root of 2x minus 3. All right, so just like in the previous example where we got fractions on the right hand side, it doesn't make it really easy to get x by itself unless we square both sides. So if we square both sides, we get y squared equals square the right hand side, and we get 2x minus 3. And if we bring the minus 3 to that side, we get y squared plus 3 equals 2x. And then if we divide both sides by 2, we get x equals y squared plus 3 all over 2. Okay, so that's step 2. We've made x the subject of that formula. Step 3 is to interchange x and y. Okay, where there's an x, we've got to put a y. Where there's a y, we've got to put an x. So this x will be replaced with a y equals x squared plus 3 all over 2. And then we've got to go through the verification process. So that's step 4. I'll just get myself a little bit more room here. So we've got to prove that is equal to f to minus 1 of f of x equals x. So that's the 4th step. Okay. All right, now what is the original function? The original function is the square root of 2x minus 3. So we've got the square root. So let's just do this one here. So we've got f to minus 1 x equals, now the original function is the square root of 2 times something, square root of 2 times something minus 3. Now what is that something in that bracket? It is simply what the inverse function is, and that's x squared plus 3 all over 2. And we're hoping that's going to turn out to be x. Alright, so what have we got here? We've got a 2 times that, so that's just going to be equal. The 2's will cancel. Goes once. So we've got the square root of x squared plus 3 minus 3. So that's the square root of x squared, and that's equal to x. Now don't forget, the square root of x squared is not plus or minus x, because we've just got the square root of x squared, and we're assuming, because there's no sign there, that's going to be positive. Alright, so we've got x there. The other verification we've got to do is f to the minus 1 f of x equals, now the inverse function is here, and that is something squared plus 3 all over 2. So that is the inverse function, is something squared plus 3 all over 2. What is the something? F of x. What is f of x? The square root of 2x minus 3. Okay, when we square the square root, we get back to the original, so we've just got 2x minus 3 plus 3 all over 2. Plus 3 minus 3 is 0. 2x on 2 is just equal to x. So we've done the verification, both verifications. Finally, we just quote our answer. If y equals the square root of 2x minus 3, therefore the inverse of x is equal to x squared plus 3 over 2. Okay, now it wasn't asked for, but it'd be interesting to have a look at how the inverse function looks compared to the original function. We've already said that y equals square root of 2x minus 3 looks like this. And that's going to go through the point 1.5. Now, this one, the inverse function, it is actually going to cut the y-axis. So it cuts the y-axis when x is equal to 0. 0 plus 3 over 2 is 3 over 2, 1.5. So it's actually going to cut the axis there. And this is going to look a bit like our parabola y equals x squared. We've got x squared on 2 plus 3 on 2. So you could actually write that as x squared on 2 plus 3 on 2. So it's like an x squared on 2 graph moved up 1.5 units. So x squared on 2 looks like that. So this one is going to look like this. Now if we were to draw y equals x, which I'll do in red here, you can see that there is a relationship. It's like a mirror image in y equals x. So here's my inverse function. So this is y equals x squared plus 3 over 2. And it is a general rule that most inverses are mirror reflections in y equals x. So if you can draw the original function, the inverse function will be the mirror image in the line y equals x. So just something to keep in mind.